All right, great. I can start out with the introduction. Thank you, everyone, so much for joining. This is another episode of Graph Builders Office Hours. Really excited this week because we have Chris from Edge and Node who's going to be talking about Graph Client and is going to be showing off some cool stuff there. As everyone knows, this is going to be recorded, so there's a good chance that the video is going to be ended up on YouTube. So if for some reason you want to remain private, just keep that in mind. But we definitely want to hear from you. So if you are interested, be engaged. We'll do the coverage of Graph Client, and then we're going to stick around here for the rest of the hour as well afterwards. So if anyone has questions or just wants to talk about anything, yeah, feel free to talk away. So without further ado, let me introduce Chris. Chris, thank you so much for joining, and I'm really excited. Thanks for taking the time to do this today. And yeah, the stage is yours.
Perfect. Thanks, y'all. Really appreciate this. So I'm a product engineer at Edge and Node, working on the UI front-end architecture for the applications that you see with like the Graph.com, Explorer, Studio, hosted service, etc. So those applications, Explorer specifically, consume. Well, Explorer is almost it's meta, right? Like Explorer uses subgraphs, and the subgraph that it uses is the network subgraph to show off other subgraphs as well as other aspects of the graph protocol, right? Indexers, delegators, other participant roles. So it is a subgraph of subgraphs, is what we like to say. And as we were building it out, when I first started, it used what you would expect: Apollo client. You'd query the network subgraph, get data, render the data, which was great. And about a year ago, the guild became one of our core dev members at the Graph, and they started working on this concept of this Graph client. And their goal was to make querying of one-to-many subgraphs easier, where they could build like in code a way to access it, to build in like some common logic themes, things like retry logic or things like failure logic, etc. And it is really, really, really well done. The team at the guild and super smart. They built some really great products. If you're checking out the GraphQL space, can't recommend them enough. And so today I'm going to show a little bit of the Graph client, talk about how we use it, how I'd recommend you use it. And yeah, let's go. So I'm going to share my screen. And I'm going to start here in VS Code, and I'm going to kind of walk through like some of the initial steps that it takes. And this, by the way, this is going to be a publicly available repo, so that way any of y'all can check it out, and kind of walk through this as well. So the goal of, like I was saying, the goal of the Graph client is to like create configuration for consuming, for sake of simplicity, GraphQL endpoints, and that starts with this Graph client RC file. So in this repo, created a turbo repo, mono repo, not a big deal. I have an API, which I'll demo here in a second, but it's rather unimportant. And then I have this Next.js application called UI. And looking at my package.json here, there are quite a few different packages that we install for this, and most of these actually are more to do with like how I'm handling certain configurations of the Graph client, which I'll go into. But this right here, and let me know if I need to zoom in, but this right here, this client CLI, this is the key, right? So if I'm installing this and I do pnp add dash dev at graph protocol / client CLI, that is the key piece that I need. This creates the necessary or it installs the necessary dependencies to it's essentially like a build client, right? So it reads your Graph client RC and then generates the necessary files. So looking at this one's very, very simple. Like I was saying, the idea is you can plug in one-to-many GraphQL or technically Rust, but let's say GraphQL clients that you want to consume from in your application. For us, this is massive at Edge and Node because the Explorer doesn't just consume from the network subgraph, it also consumes from an analytics subgraph and a billing subgraph and a vesting contract subgraph and a couple others. So handling, in that case, we're at 5 different subgraphs that we're consuming from. Handling 5 subgraphs that you're consuming from in one application with an Apollo provider becomes very, very cumbersome very, very quickly. And this cleaned that up by creating one combined schema for all of the schemas that we want to interact with, for all the GraphQL or subgraph endpoints that we want to interact with. But it can be any GraphQL endpoint, as I'll show in a second. So for this demo, I created a similar sort of situation. I created my graph client RC YAML file, and I added a simple source. I named it network because it's the network subgraph, and I told it we have a handler. It's going to be GraphQL, and this is the endpoint, and this is the hosted service Graph Network mainnet endpoint. There's a lot of configuration options I recommend, and as part of this, when I share the demo, there's a link to the Graph client GitHub, and they go through all these different configuration things. So I won't touch on all of them in this demo, but a couple that I use very regularly is this retry logic. It does exactly what it says, right? If calling to the API fails, it will retry it twice with different configured retry logic behind the scenes, and your client, your end client that is consuming from these is much cleaner. You don't have to build that in yourself, right? Like with Apollo, you don't have to do the retry link or same kind of concepts with GraphQL requests or even the fetch library where you're building it out yourself. So they handle that for you. And then I also apply a transform. And as this file grows, if I get more and more sources, subgraphs, GraphQL endpoints that I'm consuming from, it becomes really helpful to add these transforms. Primarily, you don't. To be clear, you don't need them. What they really do for you is, like, if I had 2 subgraphs and these subgraphs had entities with the same name, then that would create a collision, as you can imagine. So if I prefix them with something such as network or whatever you want to put, then that removes the collision, right? Because I would have the network account and the analytics account and the live peer account, right? So adding these transforms to prefix them just cleans it up. So yep, done. So now when I build my client instance, this reads through my graph client RC YAML, and it generates a unified schema from this approach. And that comes in here in this .graph client directory, which we add to the git ignore. So in here, I have a few different, or what it like aggregates all of my sources and creates this file. So it exposes this end schema.graphql, and this schema.graphql is the aggregation of all of my sources. It's like one combined schema to rule them all. And so as I add sources to here, this schema.graphql file can grow as we support different schemas, sources, etc. And breaking it down, this also builds TypeScript typing files for us with the exposed types, the filters, all these kind of things. And all the way down here at the bottom, we have a function called execute. And this execute function is like, well, there's an execute and this subscribe. And these are what, like, pretty much any GraphQL client uses to perform the end result of, like, okay, I need to hit a GraphQL API and call it with a GraphQL query and variables and get a result. And so this exposes this execute function, and we'll see how that's used in this concept or in this app here in a second. And then looking at the sources, this is broken up by name. So you see I have sources with a network directory, and it has the schema, its own GraphQL schema, its own exported types. And then these are barrel filed up into the index.ts, rolled up in there, and with the schema GraphQL. That's kind of the graph client. It's auto-generated, and we ignore it. So I've yet to run into an instance where I needed to actually update any of the files in there. And if you do, the next time you run your code gen, it's just going to write over it as well. So not really much reason to just let it do its thing. So I have my graph client RC. It is generated. This is another part of this. I'm not going to go terribly deep into this, but we also use GraphQL code gen. And what this does is it allows us to build GraphQL queries and get type support from that query. And this, like, this was another huge game changer for us because it allows you to define, like, its power is in defining fragments. And so you can have a component like a table, like let's say you have a table, and we'll see in a second, epochs. And in my epochs table, I can define a fragment with a GraphQL fragment that represents the data in the epoch that I want to see, an ID, a start block, total index or rewards. And that exports types that represent that fragment. And then I can type my component to that fragment type. And what this does is it means our components from the component level all the way up to the GraphQL endpoint are type safe. And that is huge, right? Like what it guarantees that if I update my fragment, or if I'm using a subgraph and the subgraph schema changes, then my app will break and let me know it at the build step instead of when I'm running live in production, right? So if I am consuming this, a subgraph, and I have a query that is epochs, and I choose start block, and I forget the ending K, and I misspell it, and I run a build, my build will fail because that's not the right word, right? Like, that's the incorrect spelling. And so this helps with typos, it helps with schema changes, and it helps create like type safe components from the GraphQL source down to the component level. Incredible. And the rest of this is, sort of configuration. I tell it what documents or what files that I want it to consume from, and then I tell it the schema, and this is my generated graph client schema, and I tell it the schema that I want it to, like, essentially check against. So it says, find me all the GraphQL in these documents, and then validate it against this schema, and then generate an output. Really cool. So let's take a look at some code. So this GQL file, excuse me, directory is generated by the CodeGen. If I want to generate the CodeGen, I run GQL CodeGen, and if I look at my package JSON here, that is just GraphQL CodeGen, and it defaults to CodeGen.ts as like its default file name. And I also added like ESLinting, so after it generates them, it lints them, runs prettier, those kind of things. And you can also run it in watch mode, where it's consistently watching. As you make changes, it'll show you what's correct, or if it's bad or whatever. So looking at my app, here is my consumption of my network subgraph, the epochs table, and we'll add on to this with type support. So I import my execute function from the generated graph client output. This is what I was mentioning earlier. I'm going to bring in, this is a generated GraphQL function that takes the input here, this input GraphQL query, and creates types from it. And you can see those types here, right? So I import this GraphQL, this like wraps up all of the types of all of my GraphQL queries that I have generated, and it creates types for them. So it'll show me, all right, so for this query, epochs query, and it goes based off of this query name, not your variable name, just a heads up. So this epochs query has a first variable that is not required, a skip variable not required, both first and skip are required, my bad. A where variable that represents the epoch filter, order by, order direction, and I then define my epochs query. Now I'm aliasing, and this is important to this conversation, because if you remember from my graph client, we're prefixing this value here, network __ to it, which means all of my references to data on that GraphQL endpoint have to be prefixed with that as well. So now you see it in my where clause, you see it in my order by, you see it in my order direction, and you see it in my query here as well. So anytime that I reference them, it has to be prefixed with this because of this prefix here. If I remove this prefix, I don't have to do that. But again, it allows us to consume multiple sources and avoid naming collisions. So I'm going to define my epochs. I'm going to pass in my variables, and I'm going to tell it I want the ID, the start block, the end block, etc. And then this is just Next.js, so I don't really want to go into it, but like I'm going to call my execute function. I'm going to give it my query, which is a typed document node, and I'm going to provide it my variables. So I want the first 100, skip 0, and I want you to order by the in block descending. And I could also do where, and this would be like a typed version, a type safe version of the where filter for the epoch, where I could say start block, or would start block greater than equal, etc., etc. So anything available at the um, epoch filter here is available to me in my query, and it is type safe. So the execute function is unfortunately not. It doesn't take generics. I've written a couple times like some wrapper functions that essentially take generics and then parse the results and kind of give you like a friendly TypeScript like this result as this. But the end result here is I have a function and it says I'm going to return the epochs from this query that is generated with my GraphQL code gen function here. And so I'm going to say, okay, I know that my response is GraphQL, so I have data, and then I want the epochs from it, and that's an array. And then in my function, like my actual JSX element that I'm going to render, in this case on the server, but I'm going to call that function, get my epochs, and build a table off of them. And I can see, okay, this is an epoch, and it has this type where it has an ID and a start block and an end block, the things that we've selected in our query. And as I add or remove things from that query, these things, that value would update. So I believe, let's run this. I think I have it running locally. Yeah, so we have this cute little demo, and in here we have epochs, and we have our fields and a table. Super easy. This in and of itself, it does provide some value. I think even if you're consuming a singular endpoint, it still provides value. But really where the Graph client shines is by adding multiple sources to it. So I'm now going to consume, because this is a Graph demo, I'm going to consume from well, in this case, testnet, but I'm going to consume from the Compound v3 subgraph running live on Arbitrum Go Early testnet. So I'm going to grab the query URL here, and I'm going to create another instance. I'm going to say, this is me being verbose. Obviously, name it however you feel comfortable with, but I'm going to say Arbitrum Go Early Compound v3, and I need handler, and it's GraphQL, and my endpoint. I'm going to modify this because I don't need this API key here. And so just making sure I did that. Yep. Okay. So I have hitting the correct gateway, GraphQL, etc., and this ID. Now, with this, as we know, like if we want to query a network subgraph, we need. Oh, sorry. One second. I'm going to add a transform too. So because we're querying a network subgraph, we have to provide a payment mechanism. Now, this could be an API key, which we know about, and also working on subscriptions. So we can pass our API key or our query key as a authorization bearer token. So we can pass it in our header as an authorization bearer token. And the Graph client allows you to do this in a couple of different ways that are really cool. So you can pass it in at context level, and I'm not going to show that one here. Well, I might here in a second, but or you can pass it in with an environment variable. So that's what I'm going to do now. Is I have a query key. It's stored in my environment at query_key, and I'm going to pass that in as my authorization bearer token. So that way, at this point, when it consumes, like when we're like a couple things like when we generate our schema, it can have access to it because that is still technically a query. It's an introspection query. And then when we're using this source in our application, it'll pass that authorization bearer token to it as well. So looking at the Graph client tools, Their documentation, by the way, is really, really good. So definitely go through that. They also have plenty of examples. So I want operation. I want these headers, right? Because this is what I'm going to pass. I'm going to pass a header that is the authorization header, but I'm not doing context. I'm doing environment variables. So I am passing an authorization header to the request that is a bearer token, and I'm calling it query key because that's what it's stored as in my .env file. So now that I have this, I am going to add my transform as I mentioned earlier. And I'm going to name and give it a prefix. There's lots of different transforms. I'm just keeping this sort of simple here. So I'm just going to say compound. And again, this is my naming convention. I'm not prescribing any sort of naming convention. It's just what I've used and had success with. So now I'm going to regenerate my client. So we're called build client, which if we look under the hood here, just calls graph client build. They also actually export their own like graph client yoga graphical editor instance that lets you see your schema, your compiled schema, and see the different things and query it, which is also really cool. But anyway, I'm going to call graph. I'm going to build my client instance. Oh, and what happened here? Oh, this might be more pain than I'm expecting. It may have gotten too bold. Um, make sure that I provide this. Make sure that I'm using the correct introspection query here. Wouldn't be a live demo if you didn't have some errors, right? Um, it's a requirement. Uh, yeah, I'm not particularly sure, and I don't want to take a bunch of time. I'm just gonna remove this really quick and see if that's it. Nope, that's not it. Okay. Um, okay. Well, I have another GraphQL endpoint, so because we're just trying to reinforce the what we're working on here. So in this case, I'm going to use the what is the latest Uniswap one? Is it Uniswap? Oh, there's so many. I'm a live peer. Let's make sure that this is running. Okay. So I'm going to grab the live peer API here. I'm going to switch from compound and then figure that out later. I'm going to re-grab my transform. I'm going to name you live peer. I'm going to name you live peer as well. And then I'm going to generate my client. And we have success. Okay. So now if we look at my graph client here, I will have multiple sources. I have my live peer source and my network source. And then my schema GraphQL generated here is the aggregation. So this does get pretty big. It is the aggregation of both of these networks, right? You can add obviously like they don't subscriber limit, but they also allow you to like limit on both ends. Like you can provide like I only want to consume these entities, or I want to exclude these entities, which can be pretty handy. So that way you can like create this schema, the unified schema, to only be the things that you need access to. So that way you're not carrying around a bunch of cruft of files that your application isn't going to need, or types that your application isn't going to need. So I do recommend looking into that as well. That's part of the configuration. So now that I have this, I'm going to create a quick page here, and we will call it, let's see, what do we want to, I don't know what a transcoder is with this case, but I'm going to call it transcoders. So we're going to create a transcoders file here, and I'm going to import my execute function again, and I'm going to import my GraphQL file again from my GQL schema, and I'm going to define my query. So I'm going to say const transcoders equals GraphQL, and I'm going to say query transcoders, and we'll keep it simple for now. So I'm not going to provide it anything. So I'm going to say transcoders again. And remember, because I prefixed this in my graph client here with live peer, then I have to do the same here. So I got to do live peer transcoders. And I don't need anything. So I'm going to do ID. Let's see. I assume you have an ID. Everything has to have my total stake, reward cut, fee share, and service URI. Keep it simple. Okay, so now I'm going to run my codegen here. So I'm going to say to build my GraphQL codegen, and this will go through now my my new query. And if I hover over this, I see that I have a type document node that will return that data type. So I'm going to create an async function, retrieve transcoders, and this is going to return a promise of my transcoders query transcoders result, which is an array. So I'm going to say response equals await, execute transcoders, and then I don't have any variables. I don't need to provide it any context. And then even though this doesn't give me type safety, I know that it's roughly response dot data. I know that part. And then in here, I alias it to transcoders, or I want to return an empty array. And then my transcoders page here. And this is the first thing this is going to do is it's going to get my I'm saying transcoders more in this day than I've ever said in my life. Retrieve. And then I'm going to render some JSX here and just say and for sake of simplicity, we'll say transcoders.length. So now if I build my app, I'm running this locally, and then I can go to /transcoders, and this should be my new built page, and I found 100. So that's not particularly exciting. So let me open up my other page here, and I'll copy my table. Welcome to coding. It's 90% copy pasting. I'm just kidding. But in this case, I know I'm going to kind of keep it simple. We'll do start block and then total stake to not really go through boring stuff. Total stake. And then if I want to iterate over here, then I can say coder.id. And then we'll do coder.total stake. And now if I look at this, I'll see a table with all these pieces of data. Pretty incredible. Super easy to do. So yeah, I think that kind of concludes kind of the working session here. Kevin, you'll let me know how you want to handle questions or anything. But to kind of sum it up, like this graph client, if you are consuming a subgraph, I highly recommend checking it out. It cleaned up our code. I mean, the query that the PR that I created to migrate Explorer over to this was pretty big, but it like cleaned up thousands of lines of code of trying to like making sure that we're connecting to the correct subgraph and querying the correct subgraph and running, because one of the things I didn't mention, and I'll actually mention it now because I think it's cool. One of the things that this does is it like, because these are technically the same combined schema that you have access to here, then you can query, one-to-many with batch querying of Like I can hit the network query and I can hit the live peer query in the same like query here. So I could do, what's another good one? Let's do subgraphs. Why not? And this is going to say network subgraphs. And for sake of brevity, I'm going to say order by created. I think it's created. Yeah, no, it is created at. And then I'm going to order direction descending, and I want the first 10 skip 0 where active true, and I want the ID, and I want the display name, and I want the owner, which is an object, so I want the owner ID, which is just the owner's address, and their default display name, which is if they selected a display name in the application, etc. So now I'm going to regen my my document here. So I'm going to recall CodeGen. And now inside of my object here, my response is not just my transcoders, but it's also my subgraphs. So now I want my change here to be subgraphs, transcoders at subgraphs, and then I want transcoders to be transcoders query at transcoders, right? So I know that this response here is all of my transcoders, so I can just do there we go. And then I can do subgraphs and do response dot date, come on, data dot subgraphs or an empty array. So now I'm returning both. So now in here I can do subgraphs transcoders. So now under the hood, it'll make two queries, right? I'll be querying the network subgraph to get subgraphs, and then I'll be querying the live peer subgraph to get transcoders. But to my end user, like this query becomes much simpler. Like instead of me having to build out the functionality to query both and then combine, and then retrieve the both results, whether I do that with multiple use queries depending on my framework, whether I do that with promise.race or whatever it might be, I have to handle that. So this does it for me. And because we can batch GraphQL, we can handle this in a lot of ways. So you can build out these much more complex pages where your query is so simple and it's type safe, right? And then you can pass this down where you're like, okay, on this page I need to get this piece of data and this piece of data. So they really do a lot of really cool stuff. They also have, I'm just going to touch on this really quick, but they also have this extension layer where in your graph client here, you can extend types. So and you can then provide custom resolvers for it. And in my opinion, the coolest thing about GraphQL is the resolver layer, which says each field can be resolved and all the way up through the chain. Like it's very circular, right? Like we have this top level type called query, and it has a bunch of queries that it exposes, but those are just fields on query, and each of the things beneath them is just a field. So it can resolve to a type, or it can resolve to an object, or it can just be another query, right? And so their extension framework allows us to, we could do something like what we do, for instance, is, if we know the owner ID from the network subgraph, we can like transpose that and extend the type to grab the ENS name from the ENS domain subgraph. So for each, and you can see that here, if we go to Explorer, and we see all these like owners. Well, these owner values are like a combination of if the user selected the a default name in the system, or it falls back to the ENS domains subgraph. And so for each of these, we extended the owner type and we added this ENS name to perform that resolution. And again, it simplifies it, it adds a little, more work at the graph client layer, and you got to have a resolvers layer. But once you build that out, this end layer here, like where you're actually building your queries, becomes so much simpler and so much easier to rationalize because you built it all out in code. Yeah, so there's a demo.
Dude, awesome job, Chris. That was really, really good. Yeah, I'm really excited about everything you showed. It's really, really cool demo. Yeah, I really love the type safety stuff too. That's really awesome. Yeah, so does anyone have a question that they'd like to ask about Graph Client to Chris or anything that he demoed? Chris, I have a question. Do you know if there's any like particular like features coming to Graph Client that's worth talking about, or anything that you think that could use some improvement? I mean, I hate to be like, the the person, but is there anything that's missing that you think would be ideal to add to the product?
As far as what's coming, I haven't heard a terrible amount. I know that they were working on consuming GraphQL over HTTP instead of HTTPS. I'm not sure all the use cases for that, but I know they've been working on that. And I also know that there was conversation. Well, you can also consume REST endpoints here. Like you could add in a REST API, and it'll like run as long as you have certain things enabled on your REST endpoint. It'll provide like essentially a GraphQL wrapper into this unified schema using data from the REST endpoint. Um, also, um, I think that one of the things I would like to see resolved is this execute function being type safe, because what we use it with Apollo. I do not recommend Apollo. This is not a Apollo chill by any means, but like with Apollo, because you can wrap basically the execute and subscribe functions into um, your Apollo client. Everything is, you get a different level of type safety, but I still prefer like TRPC or GraphQL request. So I'd love to see this execute function being types, at least generic, so that way you could do something like, I mean, this execute mesh function already takes T data TNE, right? So if this function here could be something like typed execute, and you say T data equals any, T variables equal any, and then this is going to return an execute mesh function with T data and T variables, right? Like that, and then you pass in the same args that are now type safe args, and then perform the execute. I think that would be cool. Um, Even though it's sort of gimmicky, but I think it would be um, handy to have. I think that they're also like part of this framework is that it also allows built out type safe mutations. Um, I didn't demo that because there's not much use in. I mean, we don't expose mutations from subgraphs, but there is like you can add in mutations as well, which is really cool. And you, I guess in some way you could build a mutation. I haven't tried this yet, but I would love to. But you could build a mutation that is like that calls a smart contract function. So you can have like a query that is subgraphs and then a mutation that allows you to publish a subgraph, and all of that would be wired up through your graph client. Um, so yeah, I think I made some recommendations to them, but um, we some of it's just a little like weird in how versions are handled, or like the error that we saw earlier, stuff like that. So by all means, if you see any feedback, create an issue on their Git. But other than that, yeah, not something that's really popped up of like, oh, it'd be really great if it did this.
Awesome, cool. Thank you, Chris.